And all we're gonna do today is just review. We're gonna review for the quiz without the hoodies on. You should be able to get through this today. Determine if the following functions are growths or exponential decay. So let's just go one at a time. Only say something if I call you. Martha, you can sit behind Ingrid if you want, unless you guys hate each other. You don't hate Ingrid, okay? Neither do I. Alright, first one, number 1, is it a growth or a decay? Why is it a decay? Does not have to do with A. Why is it a decay, Marmy? You think it's a growth? No, he's right about decay. Yeah, Jada? Yeah. And go ahead. Thank you. The base is less than 1. The base. Not A. In this case, A is 2, but who cares about that? The base. Base. You didn't say base. Base is a key word. You just said fraction. If you're not sure what the base is the number that's directly under the x. So like when we move to number 2, what's the base on number 2? Number 2 here. What's the base on number 2?
1.
No! Oh man. Sorry. The base is 3, yeah. So is it a growth or decay? And then, Jada, how about number 3? That is also a growth, sure. What's the base there? 2. Kiara. How about number 4? Good. What's the base there? Yes, 105. Good. Shobi, number 5. Good. Right. Number 6. Good. Alright, so it seems that we know that. That's good. Now, another part that's going to be on the quiz. Can you determine the transformations? Transformations depend on A, H, and K. So I would identify those first. Because if you know where to find that, then the fact that these are exponential functions have nothing to do with anything. Like, these are the exact same transformations you saw with parabolas. If you understood it with parabolas, the only difference with these versus parabolas is where you find A, H, and K. But once you find them, they do the same thing. So Ingrid, like for number 7, what's A? It is 2. What's H? 0. And then what's K? Doesn't matter if this is a parabola, a square root, a line. Doesn't matter the function. Once you know the transformation, doesn't do the same thing. So let's see, like if we were reading a language, if we can determine what these things are going to do. What's the first transformation? Assuming we go in order from top to bottom, what's the first transformation we're going to see, Marquise? Yeah, just so that we go in order, like just to give us an order to follow. If we're going like from first, we look at A, then we'll look at H, then we'll look at K. Very good. Vertical stretch by a factor of 2. Vertical stretch expands. Vertical stretch of 2. Okay. Anything else, Marquise? Okay. Translate. Sam, I am. I do not like them. I do not like reading them again. What's A here? Good. Most people would say 3, but good. What's H? In your paper, 8, H, H. Martha, stop throwing up gang signs. What is it? 1, good. And then K is -2. All right, so let's just go in order. What transformations do you see there? Well, you don't stretch 1, so yeah, when A is 1, you can ignore it. Good. Translate right 1, and then good. Translation down 2. Hi, Antoine. Yeah, Kiara. How come the A is what? Okay, let's see if somebody else can answer that for you. She wants to know for number 8 there, why isn't A 3? What is 3? The base. The 3 is the base. That's what tells you, like, if the question here were to be growth or decay, that's what would tell you if you have a growth or decay. The A has to be in front. You always have to have a base. Like, you always have to see the base. You don't always have to see the A. So the reason why you don't see the A is because there's a imaginary 1 in front here. That's like saying 1 times that. All right, Martha, you can join in now. You're off of timeout. Number 9, what's A? What? Yeah. And H? And K? What? So tell me the transformations. Yeah. Would you just raising your hand if you wanted to steal the transformations from Samantha? Go ahead, Caleb.
Funny question.
Vertical compression, yeah, because when it's less than 1, it kind of stretches the compression of 1/4. And then, no, why down? It's positive. Yeah. Translation, make sure you use that word. Translation up. Yeah. Yeah, man. Or shizzle. Huyen! Number 10. What's A? 6, okay. H? -2, good. K? Very good. So, can you tell me what the transformations are going to be? Good. Vertical stretch of? Wait, vertical stretch of how much? What, by what magnitude? What? 6, good, okay. And then? We're going to translate in what direction? Left. Negative, left. And land. Number 11, what's A? 1, good. What's H? 2, good. Positive 2, make sure you change the sign. And what's K? Good. Tell me the transformations. Hey, Jada girl. Good translation. Use the keyword translation. Right. Two, and then. Good. Translation of cinco. Don't stretch and compress. I didn't write up this review, but sadly, it looks like what's the one transformation that we haven't seen here? An encroachment? A reflection, yeah. What would cause there to be a reflection? If A is negative. I don't have one of those. Yeah.
Zero.
No, because it's multiplying, right? And what's zero times anything? Facts. Yeah, so you wouldn't even have a function. Yeah, you know how Brandon gets when he doesn't have a function. Go ahead, Brandon. Let's do the last one. What's A? Too good. What's H? Ah! You give up that fast? You want to ask Kiara? Yeah, hey, Kiara, look it up with H. What's the H? Wait, you know, I found somebody else in another class. Yeah, and then how about K? So then Kiara, you can steal it from Brandon then. Tell me the transformation here. Good, vertical stretch of 2. Vertical stretch times of 2. And then good. Translation. Any questions here? For the children's? All right. So for the graph, it looks like I teach is a little bit different than the other teachers do because it looks like they just teach them to do substitution. I don't know if you've gone to tutoring. I could recognize either one. If you choose to do this another way, that's fine. But basically, the difference is on the quiz. They put on the quiz already what points to plug in, whereas I'm gonna let you choose. But I want to see at least 4. It looks two. Yeah, I should be able to fit 4 points on both of these. So let's get some starting points up. First off, the way it's gonna look. So you're gonna pick the point the x's instead of me picking them for you. So first off, what type of a function, what type of an exponential function is number 13? And decay, what did I recommend to you would be good inputs to use for a decay? 0 and negative. So I'm going to use 0, negative 1, negative 2, negative 3, and hope they all fit. Yeah, looks like they should. So when you come up with these points, all you want to do is take the base to these numbers. Nothing else. No transformations. Just take, what's the base here? 1/2. So what's 1/2 to the 0 power? 1. What's 1/2 to the negative 1 power? That's a negative 2. It's just 2, good. What's 1/2 to the negative 2 power? 4, good. What's 1/2 to the negative 3 power? But wait, how did you get that? I had no idea. Well, I explained it last week. Go back and watch it on the notes if you have to. If that's not enough, but put it on the calculator. The calculator will be happy to do that for you. Take a number to a negative power, it flips the base. So that's why I recommend negatives. All right, well, before I get too excited and plot these points, now I need to transform them. Transformers, robots in guys. What's A here? Good. What's H? And what's K? So it looks like the only thing happening here is a vertical stretch. So I gave you a formula that said x plus h, y times a plus k. But anytime, if a is 1, you can ignore it. If h is 0, you can ignore it. If k is 0, you can ignore it. So here I can ignore both the h and the k, even if I'm wearing a hoodie. But I can't ignore the a. So I just got to get that a and go to each of the y's and multiply it times 2. So I can leave the x's alone. The first x is 0, then 1 times 2. So that's 0, 2. That's going to be on the graph. Then I'll leave the negative 1, and then 2 times 2. So it's negative 1 comma 4. That's going to be there. Then I'll leave the negative 2, and then 4 times 2 is 8. And then I'll leave the negative 3, and then 8 times 2 is 16. Where is there going to be a horizontal asymptote here? Say it better. We'll lose partial credit for this. Y equals 0. Make sure you put the y equals in front. So that's going to be right on top of the x-axis. You have to make sure that you do not pass that line. My points are going to be at 0, 2. My point, negative 1, 4, negative 2, 8, and then negative 3, 6, 9. And then the rest is just the sketch. As long as you get the points right, I just really care that the sketch is somewhat close. You will lose some points on the sketch if I can tell that you violated the horizontal asymptote and you crossed it, where it's not just a sketch issue, it's obvious that you're crossing it. Any questions there? Okay, let's look at the next one. What type of a function is that? It is a growth. What points did I recommend for you to pick for x's for a growth? 0 and positive. So let's try 0, 1, 2, and 3. And if any of them get too big, then we're going to give up. Let's at least try those. We need to come up with starting points. Points to start at, also known as parent points. The way you find that is to just take the base, which in this case is 2, to each of those powers. What is 2 to the 0 power? 1. How about if you're wearing a hoodie? Would it still be 1? Yes, it would be. What's 2 to the first? How about 2 squared? And then 2 to the third is 8. You get about something? 2 to the third is 8. 2 times 2 times 2. Okay, so let's do then A, H, K. A is 5, K makes H is positive 1, K is 0. So which of those can be ignored? Just K. If K is 0, you don't have to worry about it. But I have to pay attention to the A and the H. What's going to happen to the H is going to get added to all the X's. What's going to happen to the A is going to get multiplied with all the Y's. So if my first X here was 0, that 0 is going to be added to 1, comma. The first Y is 1 times 5. That gives me 1 comma 5. 1 comma 5 is going to be it. Then we have the next X is 1 plus 1. You can use your fingers, and then 2 times 5 is going to be 10. It looks like I'm not gonna have enough space for this last one because you can tell by the last one what's 8 times 5, 40. But I will have enough. Oh, I'm close to it. It looks like I barely ran out of space. But I can't just have 2 points. I can live with 3, but 4 is no good. So 2 plus 1, and then 4 times 5. So that's gonna be 320. They're gonna be the points I put on here. 1, 5, 2, 10, and 320. Where is my horizontal asymptote? Where? Say it better. At y equals 0. I cannot pass that line. So 1 comma 5, 2 comma 10, 3 comma 20. It's gonna go a little bit higher. It's gonna be like up here. It only goes up to 19. And then just sketch it, making sure that you do not pass the asymptote. Don't do it, Caleb. Don't do it. Don't pass that asymptote. Did you graph it? Why are you sitting there? You're mad at Jada? Do you want to sit there? Oh, okay. I could put Martha there then. Martha, you want to sit there in front of Jada? Are you mad at Jada? So you can sit there then next time. You don't have to move today, just next time. But I don't want to sit close. I'll make you a deal then. I'll put Jason there. You can take Jason's seat. Boys rule, girls rule. All right, let's go to the next page. I hate these at the zone. Yeah, if we have extra time, we'll come back to these. I just don't like. I don't know what the point is of graphing another 2 graphs with the same base. I don't know. But let's do the other 2, and then if we have time, we'll come back to these. So let's go to 17. They give you a graph. Let's discuss the characteristics. So assuming that no type of a reflection has occurred, is number 17 a growth or a decay based on the shape? It's a decay because as you go left, think of it this way. If this were a roller coaster, right, the roller coaster always goes from left to right. If this were a roller coaster and this were the car here on the roller coaster, would that roller coaster be going up or down? Yeah, it's going down, it's a decay. When it's going up, it's a growth. So this is the decay. What's the domain going to be? Yeah, it's always going to be all real numbers. For every exponential function, it's all real numbers. If you write all real numbers, I'm fine with it. If you put interval notation, negative infinity to positive infinity, that's I as well. How about the range? Well, if it makes you feel better for the range, answer horizontal asymptote first because the horizontal asymptote will affect the range. Where does this appear to have a horizontal asymptote? Y equals -2. So is the graph above the horizontal asymptote or below it? It's what? It's above, sure. So you can write this one of 2 ways. You can write y greater than -2. If you put greater than or equal to, it's wrong. Or if you want to put it in interval notation, it would be the -2 first with a parentheses and then a plus. Yeah. If it touched. So like for instance, like before you weren't here, but before when we were doing parabolas, right? Like let's pretend that this was a parabola that was like this maybe. And they asked us for range. Well, this parabola was decreasing and it reached 8 and then it went up, but it actually touched the 8. So when we would do this, it would be like, oh, 8 with a bracket, then a plus infinity. But an asymptote you can never touch. So since it can't actually make contact with -2, you have to use a parentheses. As it never actually it never reaches -2. Okay. You're giving me still like blank stares. Okay. Does Trey Young get it? How about a y-intercept? Where is that touching the y-axis? You know what? That's a terrible question. I don't know. You could do a what's called a regression. You can do what's called a regression and then come up with the equation of the function and then find it algebraically. But I'm not gonna make you do that. So for this one here, I mean you can put -1/2, but you don't know. Or whatever, -1.5, which is -3/2. But you don't know if it's -3/2. There's no way to really know that. Let's see if we can find the other. How about f at -3? Yeah, that one we can tell. Where is that? Yeah, it surely looks like it's passing a +2. And then when they put this, they want to know what's the x when y is 6. I can't answer that either. Wait, what's the f at blank is equal to 6? Oh, okay, no, sorry, I read it wrong. Yes, when y is I was backwards. Yeah, it's fine. Oh, you said what? -4? Okay. Sorry. Momentary lapse. When y is 6, x is -4. Before they were asking us when x is -3, y is 2. Increasing or decreasing? We already discussed this. Huh? Exponential functions, unlike parabolas, do not change direction. So it's either going to be always increasing or always decreasing. You just told me this was a decay, right? So unless it flips, which it hasn't flipped, a decay is always going to be decreasing. So you would just copy whatever the domain was and put it under decreasing. This would just stay blank and you will put none. This function is never increasing. I still haven't found out why they put this. I have a student that's with another teacher that said that the teacher said that they put this in here just so you can compare it to other functions, but I don't like that. So I actually manually took this off your quiz. Won't be asked for these. But you will be asked for end behavior. So end behavior, as x goes to -infinity, that means the left arrow. What's the left arrow doing here besides going left? It is going up. You were right. Positive infinity. As x is going to positive infinity. So that's the right arrow. Besides going right, what is the right arrow doing? Yeah, it's going to the asymptote. It's not going down to -infinity. It's going to the asymptote. This asymptote was at -2. So all you have to put is -2. I'm fine with that. But then just so you can be smarter than everybody else, I also taught you that when you get into the higher levels of algebra, like maybe very possibly in Algebra 2, definitely if you take like pre-cal or calculus, when your function is approaching an actual number and not something like infinity, you're asked to give like from where it's coming from, like where it's coming in from. So is this approaching -2 from the top, or is it coming at it from the bottom? From the top. So let me put this little plus up here. So you don't have to put that. If you just put -2, I'm fine. Okay. Is that a Euro step? You did a Euro. And the fact of the Euro step. Hey, number 18, is that a growth or a decay? also appears to be a decay. So there's two different decays here. Again, this were a roller coaster, you'd be headed down. Hyun, what's the domain? All real numbers, also written as negative infinity to positive infinity. Jada, the range. Actually, better yet, give me horizontal asymptote first. Give me horizontal asymptote. Good. So now, Jada, give me the range. No greater. Did I do that wrong the first time? Above 2. Huh? Why erase it? Did I put less than before? I put greater than, right? Y greater than 2? Negative 2? It's above. It's up. So the range would be above negative. In this case, it's positive 2, but you could put y greater than 2, or you could put from 2 to positive infinity. Oh, if the graph was below the asymptote, then it would be less than. Marmy, where's the y-intercept? Good. But this 4 is fine. You put 0, 4, that's fine too. Show me what is the value of the function at 1 when x is 1. When x is 1, what is y? When x is 1, what is y? I mean, it looks like 3 to me, unless my thing is off. And what is the value of x when y is 10? When y is 10, x is negative 2, you said? Show me, is this function increasing or decreasing? As you go from left to right, is it going up or down? So always you're going from left to right. Whenever you're asked increasing or decreasing, you always assume they're going from left to right. If this was a roller coaster going from right to left, yeah, it would look like I'm going up. But the roller coaster is always going from left to right. Whee! It's going down. And it never changes direction. So over the entire interval of the domain, it's going to be don't worry about maximum, minimum. If you want to put something here with increasing, just put, NA or none or not. What does NA mean? Not applicable. Huh? Like it does not apply. Like it doesn't apply. This is not increasing anything. As x is going to negative infinity, what's the left arrow doing? Going up forever, positive infinity. What's the right arrow doing? It's going to k. What was k? Yeah. And that's enough. You don't have to put anything else, but if you want to show off, you can put plus because it's coming at it from. Like, don't try putting that if you still don't understand what I'm trying to explain. You can just, as long as you get the 2 part, that's fine. But doesn't this plus just mean that it's coming from the top, not from the bottom? All right, so let's go back and do these then. Let's actually do let's do that. Let's go in order. Let's do 15 first. The 4th is 16. I don't think. Let's do that. What type of a function is this? If there's a decay, what did I recommend using for decays? 0, negative, so 0, negative 1, negative 2, negative 3. Sam, what is 1/2 to the 0 power? Good. Kiara, what is 1/2 to the negative 1 power? Good. Right. What is 1/2 to the negative 2 power? 4. Good. Jason, what's 1/2 to the negative 3 power? Yeah. Okay, let's just do this. If you only put 3 points, that's fine. But if you have a really good understanding of this and you want some better definition of this, even though I said that I recommended using negative, that's fine. But we can add, because of the fact that 1/2 and 4, like 4 is, because 4 is divisible by 2, let me just throw in a 1. And you'll see what happens when I throw in a positive 1. Now, what's 1/2 to the positive 1? Yeah, it stays as 1/2. But just, I'm going to get lucky and the fraction's going to cancel. What's A here? What's H? And what's K? Can I ignore any of those transformation numbers? Just H. So I'm only paying attention to A and K, which coincidentally A and K both affect the Y. So all of my X's are going to stay the same. I don't have to do anything to the X's. So this 0 is going to stay the same, but then the 1 is going to be times 4 minus 1. 1 times 4 is 4, minus 1 is 3. So 0, 3. Let me actually, I'm going to plot these as I find them. Where's my asymptote going to be at? Y equals negative 1. So far I only have a point at 0, 3. And then the negative 1 would stay the same. 2 times 4, what's 2 times 4 minus 1? 7, so negative 1, 7. Negative 2, 4. Let's put it over here for a second. So the negative 2 would stay the same. 4 times 4 minus 1 is 15. So negative 2, 15. And then I could tell I was running out of space. And no, like for me, look, 3 points, I can live with 3 points, especially if they're not going to fit. But because I saw this is going to work out, watch. And then I did a positive 1. And then 1/2 times 4 minus 1. See, what's 1/2 times 4? What's half of 4? 2. There's no more fraction. I got lucky that the numbers were divisible, so there's no more fraction. What's 2 minus 1? So 1, 1 is also going to be here. So that just gives me more definition on my graph. It looks prettier. Okay. Add more space. Next one. Is this next one a growth or a decay? That is a growth. What did I recommend using for growth? Yeah, 0 and positive. Since this one doesn't have a stretch, they should all hit. So 0, 1, 2, 3 should work fine. But I don't know why all these have 2's and 1/2 in it. Oh well. What's 2 to the 0 power? is 1. What's 2 to the first power? What's 2 to the second power? And what's 2 to the third power? Now that I have these numbers, let's transform them. Oh, wait, let's go first. A, H, and K. What's A here? H is 2 and K is. Can I ignore any of these transformation numbers? Which one? A. I can ignore A. Anytime A is 1, it's not going to do anything. So it looks like all I have to do is go to all of my X's and Y's and just add 2 to each one. This is only going to have a translation. So 0 plus 2, 1 plus 2. That's 2 comma 3. 1 plus 2, 2 plus 2. That's 3 comma 4. 2 plus 2, 4 plus 2. That's 4 comma 6. And then 3 plus 2 and 8 plus 2 is 5 comma 10. These are the points I want to graph. PR, where's my asymptote going to be? 2, good. Now we plot points, 2 comma 3, 3 comma 4, 4 comma 6, and 5 comma 10. If I were to ask you just for fun there, because if you didn't get to do it for the other two, if I were to ask you for the range here, what would the range be? What's the range of that function that I just graphed? Martha, you know? Range and a rango. Ingrid, what's the range? Definitely not less than 2, because it's above it this time, so. The graph is above the 2. So you can say y greater than 2, that will be fine. If you did it that way. In interval notation, the range here would be, I think, Caleb, you were asking about this. The range here would be 2 to positive infinity. It's above it. How about the end behavior? Or even better, show me, is this increasing or decreasing? Increasing. Okay, and then the end behavior. As x approaches negative infinity, what is f of x doing? What's y doing? As x goes to negative infinity. Still got time. As x goes to negative infinity, what is f of x doing? No. As x goes to negative infinity, that means going left. What is the left arrow doing? Now just going down, going to where? The asymptote, which is 2. Yeah, going to 2. As x goes to positive infinity, which means to the right, what's the right arrow doing? Also going to positive infinity. All right, if I see you tomorrow, quiz. If I don't see you tomorrow, then finish up that assignment that's really short this week.